Alright, so let's have a look at another advanced mechanics question. Here we're told a cannonball is launched at 86 meters a second with an angle of 45 degrees. So we're assuming this is from horizontal. Pretty much if an angle is given, usually it's from horizontal, and that's certainly the case in this question. So we need to find the initial velocity components, we need to find its maximum height, and we need to find how long it takes to reach that maximum height. So let's do the initial velocity components first. So we have cannonball launches this way. This is the y-axis. This is the x-axis. So it'll have a velocity in y and a velocity in x. This is the velocity in y initial. This is the velocity in x initial. They're actually going to be equal because this angle is 45. So this will form an isosceles triangle here. So we just need to find one of these, and then we know that they're both the same. So we will use cosine rule. We'll say cosine, this is 86 meters a second, incidentally. We'll say cosine of 45 is equal to Vix over 86. This implies that the initial velocity in x is 86 times cosine of 45. We can put this in our calculator. 86 times cosine of 45 gives me 60.81. 60.81, this is 2 decimal places, and this is in meters per second. So therefore, the initial velocity in x is equal to the initial velocity in y is equal to 60.81 to 2 decimal places, meters per second. So this was a nice easy one, because both of these velocities were the same, because this was an isosceles triangle. So this is our answer to part A. Now we're asked to find the maximum height. Okay, so for this question and for question C, we want to think about the accelerations, the velocities, and the positions. So our acceleration in x is 0. Our acceleration in y is minus 9.8. This is just gravity. Our velocity in x is just our initial velocity in x, which is 60.81. Our velocity in y is minus gravity times time, well, not minus gravity, sorry, minus 9.8, which is gravity times time, plus our initial velocity in y, 60.81. And then our position in x is the initial velocity in x, 60.81 times time, plus x naught, where the object starts. We're assuming the object starts at the origin, so we can ignore the x naught. And then the position in y is minus 9.8 times time squared, which is minus 4.9 times squared, plus its initial velocity in y multiplied by time, plus its initial position in y, which we're assuming is 0 because it starts from the origin. So we have all of these equations here. The maximum height will occur, so you need to be careful with this. Max height is such that the velocity in y will be equal to 0. When it gets to this top point, it will have upwards velocity here in y, downwards velocity here in y. At this point, its velocity in y will actually be 0. So we can set velocity of y equal to 0. This will give us the time at which it reaches this max height. And in fact, because we're finding the time first using this method, this working will answer both B and C. So we have V of y is equal to 0 is equal to minus 9.8t plus 60.81. So we're going to add 9.8t to both sides. 9.8t, this gives us 9.8t is equal to 60.81. Going to divide both sides by 9.8. This gives us t is equal to 60.81 divided by 9.8. Now we want a nice approximation for this. 60.81 divided by 9.8 is 6.21. 6.21, 2 decimal places, and this is in seconds. So this is in fact the answer to question C. The time at which it reaches its maximum height is 6.21 seconds when rounded to 2 decimal places. So we've actually answered C before we've answered B. This often happens in physics questions because it depends how you go about the question. The way we've done it here, we've found the time at which the max height is reached, then we'll find the max height. So we now know the time at which the max height is reached. We just need to find what the max height is. Well, the max height is the position in y evaluated when time is 6.21 seconds. So for B, the position in y we said was minus 4.9 times time squared plus the initial velocity in y times time, 60.81 times time. We have to let time equals 6.21 and we need to evaluate. So the position in y at 6.21 seconds will be minus 4.9 times 6.21 squared plus 60.81 times 6.21. So this will give us a position in y, or an approximation for a position in y, minus 4.9 times 6.21 squared plus 60.81 times 6.21. This gives me 188.67. 188.67. This is when rounded to 2 decimal places, and this is in meters. And so this is going to be the maximum height. So here we found the time first, because we used a method that found time first. Then we found the height. There are ways in which you could do it in the other order. It doesn't matter. So long as you're getting both of these values, and so long as they're reasonably approximated. Be very careful if your specific teacher gives you specific instructions on the rounding through the question. Be very careful. I've been very generous with my rounding through the question. Every time I've had to round, I've rounded pretty much to 2 decimal places, then used that value. That means we have errors compounded through the question. This does not matter in this question because I wrote the question. Right? If you're in a class and your teacher wants to be much more specific, they might have told you use 8 significant figures every time you round, or something like that. In that case, if you use 2 decimal places versus 8 significant figures, your answers may end up different. Right? If your answers end up different from the teacher's answers and they told you to use some other rounding standard, you will lose marks. Right? They'll say you didn't use my rounding standard, you're not getting the marks, too bad. So be very aware of that.